This Chinese satellite just did something that should be impossible. What's worse is that trillions of dollars in American stealth technology might have just become obsolete. But before we reveal how China shocked the world with nothing but communication signals, please subscribe to our channel to stay up to date with the latest technological news. The stealth advantage. It has been over 3 decades since a silent war about stealth technology has been dominating the sky, specifically in military aviation. We are talking about the F-22 Raptor, the B-2 Spirit, and the F-35 Lightning II. These aircraft were designed with some of the most unique shapes and radar-absorbing coatings, specifically engineered to make them nearly invisible to conventional radar systems. You see, traditional radar works by bouncing radio waves off objects. And then it measures the return signal. That's pretty neat, and the concept is simple. Moreover, when combined with special materials that absorb electromagnetic energy rather than reflecting it, the result? We get an aircraft with a radar cross-section much smaller than a bird, despite being the size of a passenger jet. So, they are almost impossible to detect. But here's the thing. The United States has invested over $2 trillion developing and deploying stealth technology across multiple aircraft platforms. This investment wasn't just about planes or having the highest tech. It was about dominating the air, which would put America on top of the military world. If stealth works, the US controls the skies. If stealth fails, the entire strategic foundation crumbles. And others have tried countering stealth for decades using low-frequency radars that can detect general presence, if not exact locations, along with infrared sensor tracking of heat signatures and even experimental quantum radar concepts. However, none of these methods really worked. The only confirmed stealth shoot-down in the history of mankind was in 1997, when Serbian forces downed an F-117 Nighthawk using ancient Soviet radar technology. That incident required perfect circumstances because the aircraft was flying the same route repeatedly, and the radar operators knew exactly where to look, along with tremendous luck and timing. They went on and took it down. It was a fluke and not a systematic counter to stealth's technology. But now, stealth remains. Until now, stealth remained one of the most dominant paradigms. From pilots, edgy planners, to military experts, everyone feared it. The psychological and tactical advantage is exactly what China just threatened to delete entirely. 6G connection. But here is where things get more interesting. China has been aggressively pursuing the next generation of communication technology, particularly 6G network operation in terahertz frequencies. While the world hasn't even adopted 5G completely, China has moved on to a much more advanced scale. In 2020, China launched the world's first experimental 6G network to test terahertz communication in space, which was a civilian technology development that Western analysts largely dismissed as China tried to surpass 5G. That dismissal was one huge, massive mistake. Terahertz frequencies operate at a much larger wavelength than traditional communications, between 0.1 and 10 terahertz. And at these frequencies, signals behave completely differently as they can carry an enormous amount of data, but are also extremely sensitive to interference and obstacles in their path. Chinese researchers also realized something that Western militaries apparently didn't. Those same sensitivity characteristics that made terahertz signals challenging for communication made them perfect for detection too. An aircraft that is passing through a terahertz signal beam creates a unique electromagnetic disturbance and a shadow that can be measured and analyzed even if the aircraft itself is designed to be radar invisible. This is the unique technological breakthrough that China has developed, and it's disturbing everyone. It was recognizing that the existing satellite communication networks could be weaponized as a passive detection system covering huge skies with effectively no additional infrastructure needed. Starlink experiment. Back in September 2024, Chinese researchers, managed by China's State Radio Monitoring Center, published peer-reviewed results from an experiment that sent shockwaves through the global defense communities. They successfully detected and tracked the stealth signature using SpaceX's Starlink Starlight network. This experiment was amazing, and the team also flew a DJI Phantom 4 drone, which had a radar cross-section similar to a stealth fighter, through the signal path between Starlink satellites and a ground station in the South China Sea. Every time the drone went into one of these communication beams, it created a detectable electromagnetic disruption. A scientist surnamed Yi, who built their receiver from affordable off-the-shelf components, led the researchers. Despite using a radar antenna that was the size of a frying pan, their system was so sensitive that it even detected tiny details like the rotation of the drone's propeller from the signal patterns. Think about how futuristic that is. They used someone else's satellite network, and ironically, it was the American company. To detect aircraft without needing any dedicated military radar system, the Starlink network currently has over 5,000 satellites that are providing global coverage. Each satellite is constantly beaming results to ground stations, creating an invisible web of detection beams that are blanketing the planet. A stealth aircraft is designed to avoid reflecting radar signals back to its source, but it cannot avoid the disturbing signals that are already there, passing through the space that it is going through. The aircraft's presence creates ripples in the electromagnetic fabric of the satellite network. These are ripples that can easily be detected from the ground using relatively simple equipment, just like China did. Passivity is the beauty of this approach, because traditional radars actively broadcast signals that can be detected and jammed. This method simply listens to existing communication signals and analyzes the disturbance. The stealth aircraft has no way to know that it is being detected because nothing is actively pinged at it. But how does all this change global geopolitics? Before we uncover the electronic warfare that is potentially about to come, please subscribe to the channel if you are interested in more videos like these. 6G Electronic Warfare System. Here's where things get even more interesting. Detecting stealth aircraft is one thing, but neutralizing them is a whole other level. Back in mid-2025, China unveiled what it called the world's first 6G power electronic warfare system, which is a small photonic-based platform that can neutralize even the most advanced US radars in seconds. According to the Chinese reports, this system operates in terahertz frequencies and can transmit two signals simultaneously, making America terrified. Firstly, it can jam the F-35's radar and communication system, blinding the aircraft to any threats that are around it. Secondly, it can generate up to 3,600 phantom targets on enemy radar screens, creating bleed sensory chaos. The project was led by Professor Deng with People's Liberation Army backing, representing China's strategy of surpassing Western technology rather than catching up with it. Instead of developing an incrementally better version of the current existing system, they are creating an entirely new technology that even America didn't think about. The satellite detection experiment proved that it worked in late 2024. The 6G system was unveiled months later. And those are not separate projects. They're components of the same anti-stealth strategy. Imagine this. A squadron of F-35s enters the contested airspace, confident in their stealth characteristics. Chinese satellites can immediately detect them using signal interference analysis, providing precise location data. The 6G electronic warfare system then activates, jamming the aircraft's sensors and filling their displays with thousands of false targets. The pilots will realize that they have been detected and that their own sensors are now useless. That's not just a disadvantage. That's a whole other level of dominance by China. The hunters could be hunted and stripped of their primary advantage while being surrounded by phantom targets that they cannot even distinguish as real or not. Using physics. The dominance of China is exploiting physics rather than technology itself. You can upgrade stealth coatings, redesign aircraft shapes, and try to make them as sneaky as possible. But you cannot make an aircraft not disturb electromagnetic signals that are passing through the space that it occupies. The traditional radar countermeasures work by either absorbing the radar system or deflecting it away from the receiver. But in this system, this signal isn't coming from a military radar. It's coming from communication satellites that need to maintain connectivity with ground stations. The aircraft is simply an obstacle to the satellite, and that obstacle creates detectable interference patterns. Even if the US develops new stealth materials that are optimized for terahertz frequencies, the fundamental problems remain the same. That any physical object passing through a communication beam would and will create a disturbance. The only way to avoid something like this would be by using any satellite signal beam, which is functionally impossible with thousands of satellites that are providing global coverage. Here, the US finds itself in a very interesting scenario because they are already spending trillions of dollars developing stealth aircraft. And China is potentially negating the advantage by using the communication satellite that already existed for civilian purposes. Moreover, they also have relatively inexpensive ground-based receivers that analyze the signal interference. They are turning America's investment against itself with more satellites, meaning better detection coverage. The US can't exactly ask SpaceX to stop launching Starlinks without hurting its own communication infrastructure. The limitations. Before declaring stealth technology as completely obsolete, we must acknowledge that there are significant limitations in China's demonstrated capabilities. The successful test was done using a small drone at low altitude under controlled conditions. Detecting an actual F-35 at 40,000 feet traveling at near supersonic speed is quite challenging. Terahertz signals are heavily absorbed by atmospheric moisture, and even the weather conditions, heavy clouds, rain, or fog, could significantly degrade the detection capabilities. The method works brilliantly in clear conditions, but when there are storms and the weather conditions aren't ideal, which is exactly when military operations occur to exploit poor visibility, then this technology might not be ideal to use. The drone test also occurred in the South China Sea, where Starlink coverage is dense and communication beams are plentiful. In other regions with less satellite coverage, our detection might be inconsistent or almost impossible at times. This system needs sufficient satellite density to create an overlapping detection zone, which doesn't exist anywhere on Earth. Detection is not the same as engagement. Even if the Chinese system can detect stealth aircraft, they will still need to track them down continuously and guide weapons to intercept those aircraft. The experimental system proved that detection is possible, but that's just the first step in a much larger and complex system that China is currently building. Western militaries aren't sitting idle either. The US is developing its counter-tactics, which include flying routes that can minimize time in satellite beam paths, deploying electronic warfare systems that jam the ground receiver, analyzing the satellite system, or even developing capabilities to disable the enemy's satellites that are detecting friendly aircraft. This has created a whole new race in this phase, but it's still just a race. China demonstrated a capability, but not the actual deployment of the technology. Turning experiments into battlefield-ready systems can take years and can also encounter many technical challenges along the way. Do you think China has what it takes to become the world's leader in anti-stealth aircraft technology? Let us know in the comments below. If you enjoyed the video, please subscribe to the channel to stay up to date with the latest technological updates happening around the world.